I don't even have to tell you. You can ask John. All right. Parallel lines and transversal lines. Parallel lines are two lines that will never intersect, no matter how long they are extended. Therefore, just as Shane says, parallel planes are two planes that will never intersect. Our next set of lines that we're going to talk about are skew lines. Skew lines are lines that will, if extended, intersect at some point. Now, they may not be intersecting in the sections that you are shown, but at some point, if we extended those lines, they would intersect. Right there. Right? Right. So now we know we have two choices if you have two lines. Either they're going to cross or they're not going to cross. There is no other option. So if they're not going to cross, they're parallel. If they are going to cross at some point, they're skew lines. A transversal. A transversal is a line that intersects a pair of lines. So the transversal here is this line right there. That is the transversal. I have a set of skew lines. They are both intersected by a common line. That common line is the transversal. Whenever I have two lines, whether they're skew or parallel, cut by a transversal, a bunch of angles are formed, and then those some angles have some properties. The first thing that are formed with all these angles are interior and exterior angles. When I refer to interior and exterior angles, what I'm talking about are those that are inside the two lines or outside the two lines. It has nothing to do with the transversal. So which angles are interior angles of this group? Which ones are to the inside? Angle 1, angle 2, angle 3, angle 4. These are my interiors. Which ones are my exteriors? 5, 6, 7, and 8. They're to the outside. But what I want you to be aware of, whether the transversal is vertical, horizontal like this, or if I take the whole thing and flip it like that, 3 and 4, 1 and 2, they're still the interior. They're still to the inside of the two lines. 5, 6, 7, and 8, they're still to the exteriors. Yes, sir? Get into it. Just hold that question. That'll be a good intro for me. Thanks. Reading my mind. All right, other kinds of angles that are formed are alternate interior angles. Now, we know what interior means, right? They're the ones to the inside of the two lines. When you have this alternate in front, what that means is the angles alternate on either side of the transversal. So when you get two descriptors like this, this is in reference to the transversal. This one, interior. Interior refers to the two lines. So alternate refers to transversal, and interior refers to the two lines, whether they're skew or parallel. So, which ones are interior? 1, 2, 3, and 4, correct? We listed those already. Which ones alternate? Well, 1 alternates with which? 4. So what I'm looking at is those that alternate on either side of the transversal. So 1 and 4. Alternate interior angle, angle 1, and angle 4 are alternate interiors to one another. Because what we're looking at now is how do they relate to one another. So 2, what one alternates with 2? 3. They alternate on either side. So angle 2 and angle 3 are also alternate interior angles. Yes, sir? No, they would be, they would just be interior angles. 1 and 3 would be called same side interiors, which I think is next. There we go, same side interior angles. Now 1 and 2 are not related to each other than the fact that they're both interior angles. But same side interior angles, same side refers to how they relate to the transversal. Interior is how they relate to the two lines. So which two angles of the interior ones, which two are on the same side? Give me a pair. 1 and 3. So same side, angle 1 and angle 3 are interior angles. And then the other pair, 2 and 4. Angle 2 and angle 4. Those are the other same sides. Now, this is just groundwork. We won't really spend much time working with skew lines that much because most of the properties, well, all right, I'll get to that in a minute. Because most of our properties are going to deal with when I have two parallel lines. There's other kinds of angles. Corresponding. If something corresponds to something else, that means they're in the exact same location in relation to both the two lines and the transversal. So I have four pairs of corresponding angles here. As I look at these, angle 6, it has a corresponding angle. I'm looking for an angle that is to the bottom of the transversal and to the left of the line. Which angle corresponds to 6? It's below and to the left. Which one? 4. See how it's below and to the left? So these two are corresponding angles. Angle 6 and angle 4. All right, what corresponds to 1? 7. They're both above the transversal and to the right. Angle 1 and angle 7. How about 5? Oh, Mrs. Russell turns it into a highlighter and then does it change my back? 5 and 3. Because they're both to the left of the two lines and then above. Good. Angle 5 and angle 3. And then the last two obviously would have to be 2 and 8 because they're both below and to the right. Angle 2 and angle 8. Those are my correspondings. Okay, let me get rid of all that. Because now we're going to look at a different relationship. But hopefully, since we've already had alternate interiors, you could figure out what are alternate exteriors. Well, alternate refers to what? How they relate to the transversal. An exterior would mean they're on the outside of the two lines. So which four angles are on the outside? 5, 6, 7, and 8. Okay, and then they alternate. So angle 5 is outside and alternates with what other angle? It has to alternate. 8. They're both to the outside, plus they're on opposite sides of the transversal. When you see that word alternate, they have to be on opposite sides of the transversal. So angle 5 and angle 8 are alternate exterior angles. All right, and the last one, 6 alternates with which one? 7. Angle 6 and angle 7. Alternate exterior angles. Now we have identified what they are with those skew lines. When I have all those properties with parallel lines, I get some triangle congruence. Or, I'm sorry, triangle, that's what we were doing earlier. Angle congruence. What does it mean when two angles are congruent? The shapes are the same, so they have the same measure. That means they have the same number of degrees. I want you to look at angle 2 and angle 6. How are they in, what is their position relative to both the transversal and the two parallel lines? Because they're both on the left and the bottom. First thing I have to tell you in order to do this problem is AB is parallel to CD. Now we can do this. They're both, angle 2 and angle 6 are both to the left of the transversal and below the parallel lines. That means what kind are they? Alternate interior, alternate exterior, or corresponding? Corresponding. And I'm telling you right now, angle 2 and angle 6 are congruent. That means all corresponding angles are congruent. When you have two lines that are parallel, cut by a transversal, corresponding angles are congruent. So, what are the other congruent angles? What one corresponds to 5? 1, I just told you. 5. What one corresponds to 3? What one corresponds to 4? And they're all congruent to one another. So, as I look at these, those are all corresponding angles. If you're given the measure of 1, you can say 5 is the same thing. So if I tell you the measure of angle 1 is 48 degrees, you know the measure of angle 5 is 48 degrees. And that's what all right, angle 4 and angle 5. These two are also congruent. Why would they be congruent? What kind of angles are they? Are they corresponding, alternate interior, alternate exterior? Alternate interior. So, as we go down here, these are corresponding. These are alternate interior angles. Given two parallel lines cut by a transversal, the alternate interior angles are congruent. Look at angles 4 and 5. Don't they look like they're the same amount? And they are. The last case, angle 1 and angle 8. How are they related to one another? They are alternate exteriors. Alternate exterior is also another angle congruence. If a set of parallel lines are cut by a transversal, then the alternate exterior angles are also congruent. So now we're going to start putting this stuff all together. In the figure, AB is parallel to CD. Find the measure of angle AEF. So I have AEF. So I want the measure of that angle right there. Can I do it? Well, what do I know? I have two parallel lines cut by a transversal, correct? What do I know about AEF and EFD? What do I know about those two angles? They're congruent, right? Because why? What kind of angles are these? Corresponding, alternate interior, or alternate exterior? Well, I can't figure it out for you. Are they corresponding? What's that? How do you know they're alternate interior? Well, see how they're to the inside? And then they're on opposite sides of the transversal. Alternate interior angles. Because they're alternate interior angles, I know they're congruent, so their measures are equal, which means the numbers. Remember, shapes are congruent, numbers are equal. Well, if their numbers are equal, what can I do with 4x minus 10 and 2x plus 20? Their measures are equal. What can I put in between them? An equal sign. What does that look like now? What chapter? Say 3. Looks like chapter 3, doesn't it? Solving an equation. How am I going to solve this? You got it. Combine the x's. Subtract 2x from both sides. That cancels. 2x minus 10 equals 20. Add 10 to both sides. 2x equals 30. Divide by 2. X equals 15. Is that my answer, 15 degrees? No. I have to plug 15 in right here. 4 times 15 minus 10. So the measure of angle AEF is 50 degrees. That's analytical geometry, taking the rules of geometry and applying some algebra to them. And what I did was, I knew that I had two parallel lines cut by a transversal, so I could figure out that, hey, those two angles are congruent to one another because they're alternate interior angles. What's that? Very good. If I look at this angle here, what's that one? 130. Why, John? It's a straight line. Straight angle. That's a straight line formed between these two angles. It's 180 degrees as a straight angle. 180 minus 50 gives you 130. Well, what's this one, John? What's this one? Yeah, these are vertical angles, right? They're congruent. Good. We're getting ahead of ourselves, but this will really help you. Well, what's this one? 50, because it's congruent to that, right? Which means, what's that one? What are these two then? If I have two parallel lines cut by a transversal, how many different angle measures do I have? 2. That's it. It's either, there are only two different numbers there, 50 and 130. Two parallel lines cut by a transversal, you're only two different numbers for the angle measure. If you figure out one, you can figure out the rest of them. All you have to have is one given. All right. In this figure, AB is parallel to CD. So two parallel lines cut by a transversal. Find the measure of angle BEF. BEF. EF. That one right there. How am I going to do this one? Oh, good. Same way as I just did this one, right? Why can I do it the same way? These two angles are what? Well, which one is it? Yes, they are corresponding because this one's to the outside. They're both to the right of the transversal and below the line. So these are corresponding angles. But what do we say? Corresponding angles are congruent. So 7x plus 40 equals 3x plus 80. Solve for x. Subtract 3x from both sides. That's 4x plus 40 equals 80. Subtract 40 from both sides. 4x equals 40. Divide by 4. X equals 10. You can plug it in here. X equals 10. 7 times 10 plus 40. 70 plus 40. 110 degrees. Which means what's the only other number for all these angles? 70. So if that's 110, that's 70. 110, 70, 110, 70, 70, 110. All you need is the measure of one of them. You can fill in the other 7. (204), 205, 1 to 34, skip 31.